Right. Okay. Good day. Welcome to day 2 of this electrical safety specialist course, which is a preparatory program for Certified Electrical Safety Compliance Professional (CSP). So, in the last session, we discussed about how the course content, what will be the course content, and what are the requirements of different domains which you have to pass in order to clear your CSP exam. Then we discuss about standard, how the standards look like, what are the different type of the chapters in these standards, and some uh, case study we did in which I tried to explain uh, what are the main points on which uh, this standard focus on basically. Then we discuss about this essential elements of safety in NFPA 70E, and we saw that these are the main 5 points or the 5 areas in which the 70E focus. First thing is that it focuses on establishing an electrically safe work condition. It talks about development of your electrical safety program. It talks about developing and training people, identification of a qualified and unqualified person for an organization, and then to do some planning activity in order to eliminate or reduce the energized work which has been performed in your organization. Then it talks about carrying out the risk assessment. The risk assessment covers both shock risk assessment and arc flash risk assessment. Additional measures for protecting workers, those who are performing some justified and energized work, that is also covered in this standard. We discuss about the definition of a qualified and unqualified person as per 70E, and what actually makes a person qualified person, and if he does not fulfill the requirements as which is considered as per 70E to be a qualified person, then he becomes an unqualified person. So a person need to be qualified person for a designated task. For a particular task, he cannot be qualified person for all the tasks. So a person will be qualified person for a particular system, voltage level, for a particular equipment. So, and when you will going to face this type of the questions in exam, just try to remember that a person need to be qualified person for a particular uh, particular equipment task which he is performing, and the system. Right. Then we discussed that this NFPA 70E standard is not only for the employer, or it's not only for employees. This standard covers both employer and employee responsibility. So if any incident happens, so it's not only the employer who will be responsible, but the employee will be also responsible. Employer will be responsible, he is overall responsible for protecting personnels who are under his control. But once an employer have provided them the policy, the work procedure, the required PPs, the required training, and other administrative control, if the employer have provided them, now at site, it's equally the responsibility of an employee to apply those policies, procedures, and then to apply those safe work practices. So if any incidents happen, and the reason of that incident was that the employer had fulfilled its responsibility, but employee did not um, did not apply those. So in that particular case, the employee will be responsible for the incident as well. For example, the employer have provided them the required training to how to perform the risk assessment, the shock risk assessment and arc flash risk assessment, and they have provided them the required level of the personal protective equipment as well to perform some justified and authorized work. But once they have done this all thing, but it's still the employee um, are not following those policies and procedure, then the employee will be responsible as well. So in exam, they will going to try to test your knowledge about this point as well, whether whether the 70E is written in such a way that it makes employer responsible for all the incidents or the accidents happening within an organization, or there are some employee responsibility as well. So while answering those type of the question, please bear in mind that the employee have equal responsibility in NFPA 70. So there will be number of clauses which we will going to see as we move on. In those clauses, you will going to find that the employer and employee both are responsible for uh, or in cases the employer have provided all the thing, but employee did not comply. So you might going to find similar type of the situation in the exam. Okay, so the focus of NFPA 70 is about protecting the employees who is put at risk of an injury from electrical hazard rather than what the employer has done to meet their obligation. In exam, the questions will be like this, like that the 70E is adopted by employers to fulfill OSHA obligations. So this answer is not correct. The employer are using or adopting NFPA 70E for protecting employees only. It's not a mandatory requirement of OSHA that you have to adopt 70E requirements. OSHA require that you have to protect your employees, whether by following the 70E requirements or any other requirements is up to employer. Okay, so 70E is basically been adopted by employees in order to protect employees under the control of the employer. So who is put at risk from an injury from the electrical hazard rather than what the employer has done to meet their obligations. And FPA 70 first priority is the elimination of the electrical hazard associated with the task. Then we discuss about what is the purpose of an FPA 70 is to provide a practical safe working area for employees related to the hazard which is arising due to the use of electricity. And then we discuss about what is the difference between the working area, how it is yani, what is covered in the working area. So if I'm standing in front of any printing machine and there is some panel behind that printer from which it is basically put on and off, or there is a breaker there, so that is not the working area. But if there is some problem have occurred, that printing machine is not working, and any electrician will going to come and will going to open that panel in order to access the breaker, in order to check whether the breaker has stripped or breaker has melted, or there is or some cable have become loose, or breaker have become faulty, etc. Under this under now that area is being converted into the working area. So all the requirement for safe work practices as per 70E will be applicable, right? Any questions up till now on this working area concept?
So that's okay.
Okay. Now, if we look into the focus area of 70E and why the electrical safety is important. So this slide I have taken from one of the training program of 70E. So this slide says that if you talk about any other type of the hazards in your organization, so if there is around 300,000 risk behavior, so the chances of converting those 300,000 risk behavior into near misses are 30,000. If we have 30,000 near misses, so the chances of recordable injuries are 300, and if we have 300 recordable injuries, so the chances of fatality is 1. So the ratio of safety triangle is approximately 300 is to 1. But on the other hand, if we talk about electrical hazard, and if there is similar type of the risk behavior, near misses and recordable injuries are there, so the chances of fatality is 1 per 10 recordable injuries as compared to 300 per 1. This shows the gravity or the or the importance of electrical safe work practices at location. So if you are dealing with other type of the hazard, so the chances of fatalities are less as compared to those people who are working with the electrical hazard. This is the main focus area of 70, how to save people from electrical hazard. On the other hand, what's the secondary priority? The secondary priority of NFP 70 is to safeguard uh, is to safeguard uh, the uh, the instruments or the equipments which we have in our organization, so that they does not cause injury to the employees who are working around. If in exam the questions comes like that, the priority of 70E is to increase your reliability, is to decrease the maintenance cost, is to reduce the insurance, is to increase the production. So all the answers will be no in that particular case. The only priority of 70E is human safety. Okay. If you are performing those human safety activities and you are taking care of your assets, then it will going to result in increasing the life of the asset. It will going to result in the increase of its availability, lower maintenance cost, lower insurance, high profitability. So those are basically indirect advantages or the benefits which you can drive from by applying 70. So this examples or this slide can be helpful if you want to sell to your management that you want to apply 70. So if maybe if your organization is not only focusing on safety, but they also take into the consideration the commercial things more. So these are the factors which you can sell them to apply the 70 as well. But the 70E priority is not these. The 70E's priority is only about the human safety or the employee safety. So what you can sell to your top management, if we going to apply the 70, the safe work practices, the chances of the replacement will be low due to the maloperation or if we determine that only qualified person will be operating our assets, so the chances of error will be low. So the chances of equipment damage will be less over the period of time. So if those risk you have reduced, so the replacement cost which will going to incur due to maloperation of or due to the faulty operations of your assets will be reduced. Secondly, unknown duration outage. Now I'm taking a shutdown. I'm establishing an electrically safe work condition. I know that it will 30 minutes. It will be the shutdown for next 1 hour, 50 minutes, etc. But if I'm trying to bypass those known shutdown duration and trying to operate and trying to work on the equipment on the live system, and if any incidents happens, there is some flashover happens or some incident happens due to human error or due to any other reason, so the asset will be completely damaged, or it will be damaged to that extent that it will require complete replacement. So that complete replacement might require 10 hours, 20 hours, or maybe more than that, because non-availability of the spares or the non-availability of the equipment itself. So so the chances which you are taking when you are performing work on the live system is that you are moving from known duration shutdown to an unduration outage as well. High insurance cost. If in any industries the number of incidents are high, okay, if the number of incidents are more, so a company needs to pay high insurance cost, because from the insurance point of view, it will be like that the equipments are not safe here, the humans are not safe here. So if their boss wants to make do the insurance of the company, then they have to pay the high insurance cost. Loss opportunities in terms of what? Loss opportunities like uh, if there is an unknown duration shutdown, the loss opportunity for example will be like that. I've not been able to deliver the projects. I've not been able to fulfill the customer requirements on time. So the customer in future will not be giving me the projects. They might be going to other competitor, though uh, those who are able to deliver the projects on time. So the loss opportunities will be there. The next thing is the regulatory fines. We have seen in the first case study that due to those incidents, the regulatory body is visiting those organizations, and they are penalizing people and the employer or the management, because they have not fulfilled their responsibility. Last is the reputation damage. Reputation damage, if an industry, for example, industry X has this much of incidents happening per year as compared to industry Y, so it will also going to affect the reputation of the organization. So electrical safety, asset safety is the second priority of 70, which is covered in the chapter number 2, safety related maintenance requirement. So the safety related maintenance requirement of chapter 2 focus on those maintenance requirement which will going to save or safeguard people from electrical incidents. Again, those safety maintenance requirement will not going to increase or decrease the points which I have written here. But by applying those requirements of chapter 2, you will be definitely uh, gaining these type of the advantages. Right? Any questions on this one? So just keep in mind that from the exam point of view, the 70E priority is employee safety. They will try to dodge you through different type of the question, but you have to keep in mind that the 70E priority is employee safety.
Yeah. So for this one, for the priority or the losses, so sometimes they call it direct and indirect costs.
Mhm.
So like what we see there in the case study that was, and what we are here in the list, in this list, all these are indirect costs, right?
Yes.
So the direct cost is like the injury insurance and all, but fines, reputation, loss of business, downtime, and all such things are indirect cost. So you need to convince the management. We can also say like an example of the tip of the iceberg, that there can be direct cost what we can see, but indirect cost can be huge and more than the direct cost. Like what are here are indirect cost, and those are like too much, any unlimited we can say.
Yes. So for management buy-in, you can add those costs and can uh, get their buy-in for implementation of this standard. But from the exam point of view, uh, we have to be very clear that the priority of 70 is about employee safety. Right, let's do some knowledge check. You can write your answer in the chat box. The amount of training you need is directly related to yes, please write your answers in the chat. Yep. Answer option A is the right answer. The hazard involved in the work is the right option. Right. Let's move to Article 100, which is about the definitions and important concepts within NFPA 70E. So you will going to find different type of the definitions in this article, which might be more than 80 or 90, but we won't be covering all those definitions. We will be focusing on only those important definitions which have an impact and which needs to be discussed. Other type of the definitions are simple, which you can read yourself, and if you require any explanation of those, we will going to discuss separately. So everyone knows what the definitions of the hazard is. It's a source of possible injury or damage to health. Hazard can refer to all aspects of technology, environmental factors, and activities that create the risk. So what is risk is basically the combination of likelihood of occurrence of injury and damage to health and the severity of injury or damage to health that results from the hazard. What's the risk assessment? It's an overall process for identification of the hazard, estimation the likelihood of occurrence of injury and damage to health, and estimates the potential severity of injury or damage to health and determine if protective measures are required or not. Here in 70E, what the risk assessment is basically divided into two types of the risk assessment. One is the R-flash risk assessment, and other one is the shock risk assessment. So whenever uh, in 70 you are going to hear the word of the risk assessment, you have to categorize those risk assessment into the shock risk assessment and R-flash risk assessment. So there will be some situation in which the shock hazard present, but R-flash hazard is not present. There will be situation in which R-flash hazard present, shock hazard does not present. There will be situation in which both will be present, and the fourth situation will be in which both are not present. So how those situation or scenario will be developed, those we will discuss shortly. Right. Let's have a look of what the electrical hazard is defined as. You can use the soft copy if you have, in order to define or find how the electrical hazard is defined in the standard. Yeah, the right option is a dangerous condition such that the contact or equipment failure can result in electric shock, R-flash burn, thermal burn, or the blast injury. So the annexure K of this standard talks about the electrical hazards, and this standard only talks about the hazards uh, related to the use of electricity. So in this standard, you won't be finding hazards related to the trip hazard, fall from height while working on overhead poles, towers. No, those are not covered here in this standard. So the electrical hazard, uh, what is covered in annexure K is related to the electric shock, arc flash burn, thermal burn, or the arc blast injury. So these are the four type of the hazards covered in the standard. The NFPA 70 standard for electric safety in the workplace provides in-depth information about the safe work practices and practices to protect lives and reduce injury, OSHA violation, and liabilities. So if we look into this annexure K, there you will going to find some general categories of those electrical hazards. So what are those categories? There are four categories: electric shock, arc flash burn, thermal burn, and arc blast burn injury. So if we look into this one, electric shock, we know that the electric shock is due to the passage of the current through the body. And due to that passage of the current, there is an electric burn is created, which is called a conductive burn. So this basically burn is caused by the current which is flowing through our body. So in this type of the burn, we will be having an entry wound and exit wound, and there will be a burning of the organs, which will be basically in the path of the current flow. Arc burn are basically occur during an arc flash event. An arc flash event is such a event in which there is a high amount of energy is released due to equipment failure, and that basically is calculated in terms of the incident energy. Once an arc flash event is over, and if a person is not wearing an appropriate PP, so the burn will going to continue. The clothes will going to catch fire, and then it will be continue to burn for a definite period of time till that arc is quenched. That is basically covered in the thermal burns. So generally occurred during an arc flash incident caused by the radiant energy and contact with hot gases and the molten material. So the burns which are caused by the radiant energy are the arc burns. The burns which are caused by exposure to ejected hot gases and the materials, those are basically the thermal burns. The burns which are caused by the conduction of electric current through the parts of the body, it is basically covered in the conduction burns. Let's look at one of the video of the E hazard. It talks about the conductive burn. It is audible. The voice is audible or not of this video?
There is audio, but a bit less, I guess. Volume is low.
Now it's okay. Now it's okay or not?
No, sir. Quite low.
Quite low.
All right, today we're going to be talking about
That's
what
okay?
does current do to the human
Yes, sir,
body
it's okay.
to get shot.
Okay. Let me.
All right, today we're going to be talking about what does current do to the human body when you get shocked. And I got a volunteer named Charlie who's agreed to give his life for us to show us what happens inside your body. And let me introduce you to Charlie the hot dog. Does anybody know what a hot dog's made out of? You probably don't want to know or you'd quit eating these things. But basically it's a combination of meat and moisture, and it very closely represents the human body. So what we're going to do is we're going to put Charlie on this special hot dog cooker that we prepared for him. And we'll just slide him on there. And what I got here is there's going to be 120 volts applied to the hot dog. Current's going to flow through him. And what we're going to observe is he's going to cook from the inside out. The ground rod is disconnected. I'm connected into a GFCI. And as soon as I plug this thing in, I should have 120 volts across the hot dog. So I'm going to put my safety glasses on, and I'm going to put my rubber gloves on because this is going to be energized. Now, those of you sitting in the front row, you may want to move back a little bit. One of the things I've learned over the years of doing this test is hot dogs are like people. No two hot dogs are created equal. And I never know what these things are going to do. So if it blows up, it's going to spray hot dog guts out across those of you in the front row. So you may want to move back a little. All right, so we're going to plug Charlie in. And what do we see? Absolutely nothing. So let's take our voltmeter and let's just see how much voltage we're putting on Charlie. So I put it across the two terminals and I measure 120 volts, right on 120. Do you see anything happening with the hot dog? Nothing. Nothing is going on. Now this, because the ground is disconnected, represents you with a drill that somebody cut the ground pin off on. And it shorts out, and now you're laying on the ground, held onto this drill, and you can't let go, and you're getting cooked like Charlie. Now we're starting to see a little bit of smoke coming out of the end of him. And that's very common with what you'll see on an injury. You'll have an entry wound and an exit wound, all right? But externally, what do we see on Charlie other than smoke coming out the end of him? Nothing. So let's look and see what happens that soon as I establish a ground, I should hear my GFCI trip, right? Charlie's sitting here just cooking away, but externally, do you see anything? No. Watch. Did you hear the GFCI trip? As soon as I got a ground circuit, my GFCI tripped. All right. So let's take Charlie. He's now dead. He's laying on the floor dead. What do you do on an accident when somebody dies? EMTs show up, they pick him up, and they do what? They haul him off to the hospital. Do we see anything on Charlie? Nothing other than an entry and an exit wound, which is very common. What happens to a dead person when he shows up at the hospital? They do an autopsy. So let's take Charlie, and we're going to do an autopsy on him and see if he cooperated with us to show us what happens to the human body when you get electrocuted. There's what happens. This, guys, is your guts, your liver, your kidneys, your vital organs. Externally, nothing. He's got a little bit of a temperature, but no external damage. Everything has been done internally, and his guts have been cooked out. Now here's the scary part. This happens every time you get shocked. The order and magnitude of it depends on the duration of the shock and the value of it. 20, 30, 40 years later, your kidneys fail, and you don't know why. And it could have been as a result of getting a big shock back in your 20s. So the bottom line, guys, the message here is be safe, wear your rubber gloves, and don't get shocked.
Yes. What's your opinion about this video? This is about the conductive burn, which basically occurs due to the flow of current from the body. Any opinion or any comments on this one? Okay, let's move and see what is basically the arc flash burn and what is thermal burn.
This mannequin is wearing polyester cotton shirt and pants.
So this person is wearing only polyester cotton shirt and pant. He's not wearing an arc rated clothing, and he's working on some low voltage system, LV system, which is operating at 400 volts.
We're targeting category 2 here.
So category 2 term, it is being used. So category 2 was used before. Now in new standard, it is basically based on the amount of incident energy, whether the incident energy at that particular location is 4 cals per centimeter square, 8 cals per centimeter square, 12 cals per centimeter square, 40 cals per centimeter square. So these type of the terminologies will be used.
have a large arc and an immediate fire. And notice that the back of the garment is on fire. And we have a large arc.
So basically, due to this arc, the amount of energy which is incident on a person, and he got burned due to this arc, that will going to fall under the arc burn. And once the arc is over, and the burn and the person will going to continue to receive burn due to this hot gases, molten metal, and the fire on the clothing, that will going to fall under the thermal burn, third category.
And an immediate fire. And notice that the back of the garment is on fire immediately, even though the arc never hit him in the back. Stop, drop, and roll is not going to put this out. This fire is too aggressive.
So arc flash event is over because it has been interrupted by the operation of the fault current, but this thermal event is still on.
For that, the pants are on fire as well. It's hard to see right now, but when our firefighter moves the mannequin, you can clearly see that the pants have ignited as well, and the shirt within seconds is almost completely burned off the mannequin. Here you have a split screen slow motion view at 3000 frames.
So up till this point, it's an incident energy in the arc itself. So a person who is receiving this amount of incident energy, that will be called as an burn caused due to an arcing fault, or it's basically the categorization of an arc burn. You will notice this arc or the incident energy will soon be diminished due to the protection system which will going to operate and clear the fault.
This mannequin is wearing polyester. Stop, drop, and roll is not going to put this out. This fire is too aggressive for that. The pants are on fire as well. It's hard to see right now, but when our firefighter moves the mannequin, you can clearly see that the pants have ignited as well, and the shirt within seconds is almost completely burned off the mannequin. Here you have a split screen slow motion view at 3000 frames a second. You get a terrific look at the arc. Comes out, hits the mannequin, and bounces to his right and left and down, but never gets his back. And in a moment here, as the arc starts to subside, you'll see the garment on fire as the smoke clears and starts to rise. It's an outstanding look as pieces of burning and melting polyester cotton are being thrown away from the mannequin on fire, and the smoke's lifting from his knees on up, and you can clearly see the garment on fire. This sort of an incident is going to result in catastrophic or fatal body burn. These catastrophic and fatal injuries can be prevented by wearing the appropriate PPE, including flame-resistant fabrics.
So how the shock hazard or the conductive burn can be prevented if we are working on the system which have been put into an electrically safe work condition, or if we are using the shock protection PPs. So this shock hazard and the conductive burn can be eliminated. How about the arc flash burn and the thermal burns? So these type of the burn can also be eliminated if you are working on the system which has been put into an electrically safe work condition. If not, then how it can be these two can be prevented if you are performing some justified and authorized work on the light system. Then these can be prevented by wearing an appropriate PPs which are arc rated. Okay, so if you are using an arc rated personal protective equipment, then this arc burn and the thermal burn can be mitigated. Any questions up till now on these type of the hazards?
Sir, about the timing, the arc flash normally is like part of second, or how long it exists?
It depends on your protection trip time settings. If your primary, if your protection clearance time is quick, it will going to clear the fault as quickly as possible. And if the fault is being cleared quickly, that means the arc flash will be cleared soon. But in cases if the protection is not being able to operate, or your mechanism has stuck and you are not and that has not been able to open the circuit, that means it will going to take more time. The higher the time, the greater the incident energy will be there. So there is a relationship between the incident energy and the time, which is called, it's directly proportional to the time. So the greater the time it will take to clear the fault or to open the circuit, the higher will be the incident energy. So that's why as we move on, we will discuss that the maintenance requirement focuses on maintaining those aspects so that the fault is clear in the shortest possible time.
I think I think in last session we saw in like arc flash boundary, like
Yeah.
it starts from, we can get like 1.2 1.2 cal per centimeter square, and it's kind of a second degree burn. Like
Yeah, basically 1.2 cals per centimeter square is the point from where the 70E says that the arc flash hazard exists. So below 1.2 cals per centimeter square is still a person can get first degree burn or a redness or those type of the thing, but that does not, less than 1.2, the person will not be getting second degree burn. So above 1.2 cals per centimeter square, it's a limit at which a person gets a second degree burn, and from this point 70E requires that you should provide the person with the required PPs to protect him from the arc flash, and if it is not justified and authorized work, you have to establish an electrically safe work condition to perform the task.
sir, in last session I had like I wanted to ask, normally if you visit like such facilities where you have like switch gear rooms and such things, there they have like cabinets, any installations, any switches you can say. So they have like arc flash labels over there, and like of course arc flash labels have boundaries, like all those safe clearance or distance. But sometimes it is like this first thing is like for a common person, or like a person in safety, how he can like make sure the distance is. Sometimes maybe if sometimes those are in center, and then on like it is sandwich, there are just crossways and like aisles in between the such installation. So how do they like make sure in normally to be more alert and more of control?
Basically, as for 70, if you are not performing any task and the bus bars are not open, so this arc flash boundaries and the shock protection boundaries and other boundary does not exist. These boundaries only exist when the bus bar or the energized part are exposed. Okay, so under that condition, in which you are visiting some switchgear room, in which on the right and on the left, on both sides there are switchgear installed. Okay, so it's still that the boundaries does not exist. Boundaries exist when the panels is open or the conductors are exposed.
Okay, so you explained in the last session that it is like comparatively, you can like you can say there is no comparison in between. If they are open or if they are closed, then it's a like huge difference. So we can say any NF this 70E is like focused for once it is exposed or it is open, or like.
Yeah, let me explain you from this figure which we have kept for future discussion. If this panel door is closed, these boundaries does not exist. If this panel door is open and I'm interacting with that particular equipment, then these boundaries exist: the arc flash boundary, limited approach boundary, and the restricted approach boundary. If this panel door is closed, but I am performing some switching operations, I'm interacting with this particular equipment locally or from remotely, then the boundaries will going to exist. So putting it simple, if the doors are closed and secure, there is no exposed bus bar or conductors, and no one is interacting with electrical installation, these boundaries does not exist. You can have a limit of approach related to your own guidelines and safety, but you cannot say that this is an arc flash boundary, this is a limited approach boundary, or this is a restricted approach boundary. Okay, if it is closed, but someone is performing some switching operations from remote using a SCADA or RTU, the boundaries will be in place. That's no person should be within the arc flash boundary. One of the incidents happened in when I was working with one of the organizations in UAE, that that the maintenance people completed their work. They gave the clearance to the team. They came out of the 11 kV switchgear room. They closed the door of that substation as well. And the remote operations was performed from the control room, which was around 10 kilometer away. So using RTU, they performed the operation. And that Ringman was basically an oil filled RMU. There was a blast happened inside that Ringman unit, maybe due to some maintenance issue or other problems, and the oil spill and it resulted in burn injury to the people who were standing at a considerable distance. So that basically they did not take into the consideration that flashover could occur in this newly maintained equipment, and it could be one of the risk of burn due to the hot oil. So if you are performing some operations from the remote, then this boundaries will be there. Okay. Next definition. What is defined as an electrical safety? Right. B is the right answer. Identifying the hazard associated with the use of electrical energy and taking precaution to reduce the risk associated with those hazards. Right. What about C? A documented system consisting of electrical safety principles, procedures, and process that direct activities appropriate for the risk associated with the electrical hazards. Can you think of what this C? We have used this term up till now. So what will be the right terminologies? No, it's not a risk assessment. It talks about the documented system.
Yeah. So documented system for, yeah, we only talk about the risk assessment like arc flash risk assessment and uh, electric shock.
This is basically the definition of electrical safety program. So when you will going to view this electrical safety program, you will going to find that it's a definition of electrical safety program. Last one, D. A state in which an electrical conductor or circuit part has been disconnected from the energized part, locked on and tagged in accordance with the established standard, tested to verify the absence of voltage if necessary, temporarily grounded for personal protection.
This is some, I guess, electrical safe condition.
Yep. Establishing an electrically safe work condition. Jazib has also put it right. This is the definition of electrically safe work condition. ESWC, electrically safe work condition.
This is a motor control center and
Okay, let's view another video related to this arc flash event. Now this person is wearing the right personal protective equipment (PP) for this amount of incident energy available at that particular
This is a motor
location.
control center and a category 4 arc, 35 calories, 15 cycles. No fire on the 40 cal flash suit. Slow motion, this is a massive arc. You can see the cycles pulsing and pulsing and pulsing, and molten metal going everywhere. Huge arc. And yet, because it was a 40 cal flash suit designed to handle an arc of this intensity, there is no fire. Frame by frame, once again, you can see the arc clearly leave the motor control center and leap 4 or 5 feet out of the gap, envelop the mannequin, and continue to rocket out both up and down.
Right. So if a person is working on the light system, and it's justified and authorized work, and he's wearing the right personal protective equipment, then it can save life.
This is a motor.
So about electric shock, arc flash, and 70E. Electric shock hazard is known since beginning, when these electrical hazards were initially determined. So it's sort of a mandatory requirement for all the employers to provide a safeguard to their employees against the electric shock hazard. But what about arc flash hazard? I think 3 years or 4 years back, in most of the companies in Pakistan, India, and Bangladesh, they don't consider arc flash hazard as an electrical hazard. So in most of the companies which you will go to visit, you won't be finding those risk assessment performed, the arc flash risk assessment, and the outcome of those risk assessment is the boundaries requirement and the correct amount of the personal protective equipment PPE's requirement. So till now, most of the organization does not recognize arc flash hazard as an hazard, and they don't recognize that it is controllable, and if it is, and you can provide a certain amount of personal protective equipment in order to safeguard employees as well. But you will be astonished to hear that since 1982, arc flash hazard was identified as an electrical hazard, and since 1995, this arc flash hazard is a part of the NFPA 70E standard for electrical safety in the workplace. So in case if any incidents happens in any organization and the employer or the safety manager, safety officer says that we did not knew about this hazard, and that's why we have not performed this hazard, and we have not performed any risk assessment, and we have not proposed any control against those hazards, then those employer or the people in charge won't be able to justify or defend themselves if there is some criminal activity or if they are facing any criminal charges in UK or in US or in Canada. Now maybe this type of the things by awareness will be one of the requirement, might be one of the requirement coming in the Middle East as well. So now it is becoming more and more it's becoming one of the requirement from the safety organization that you should study, you should carry out a risk assessment for your own of your complete facility. It's the responsibility of the employer, as stated in the 70E, that it's their responsibility to carry out the risk assessment to identify the amount of incident energy available at individual location, to provide them with the equipment labeling at that particular location, and to apply the controls as well. So no supervisor, no employer can get away with this explanation that we did not knew that arc flash hazard is basically it's identified and it is controllable. Still, 98% of the occupational fatality is happening in the organization due to electric shock rather than the arc flash hazard. But the magnitude and the impact of the arc flash hazard is so much devastated that that only 2% of those occupational fatal things are been happening, but it has been highlighted more. So more and more organization, there is a stress on organization to adopt policies and procedure in order to eliminate this or to control this hazard in their organization. Among those 98% of the fatal occupational electrical injuries at workplace, 40% are occurring at 250 volts and less than that voltage. So electric shock is occurring on the low voltage side. So this is the focus area in which we should focus on training our qualified employees as well, that low voltage does not mean low risk. It has the equal amount of risk or more risk in which the high amount of incidents are occurring in an organization. Yeah, it is right. Arc flash, the amount of heat generated and the temperature rise is around 35,000 degrees Fahrenheit, which is around 4 times more than the heat which is generated as compared to the sun. And I think iron melts at around 8,000 to 12,000 degrees Fahrenheit. So it is like this. So quickly going through the definitions given in Article 100, what is a shock hazard? A possible source of injury or damage to health associated with the current through the body caused by the contact or approach to expose energized electric conductor or circuit part. So electric shock is not received only when I'm coming in contact with the energized electric conductor or circuit part directly. If I am approaching those energized electric conductor or circuit part, then still there is a chance of electric shock and electrocution as well. For example, just remember the example of the candle. If you lit a candle, it's not necessary that you should touch the tip of the candle in order to feel its heat. If you are coming in such a close proximity only, in that particular close proximity, it's more than enough to make you feel that it's heat. Okay, so you are not touching the candle tip, but you are in so much close proximity that that you can feel the heat of those candle tips. Similarly, for the shock hazard, you don't need to come in contact directly with the electrical conductor or circuit part. You might be approaching in some close proximity in which you are within that range. The electric it can cause you, if you are in such a close proximity, that then it can cause you electric shock due to arcing over phenomena. In the arcing over phenomena, basically the electrons jump through the insulation or the air gap and can cause you electric shock. So most of the electric shock are defined in terms of step potential and the touch potential. These are the definition you will going to find in Article 100. So what is the step potential? Step potential is this type of the electric shock in which current will going to enter through your one leg and will going to exit through the other leg. So it's an entry point and it's an exit point of your current passing through the body. Any other combination of current entering into the body and passing through it, that will be covered in the touch potential. For example, from hand to hand, from hand to feet, from head to feet, or any other combination. So all those combinations are basically considered as a touch potential. 98% of the fatal accidents occurring due to electric shock, and out of those, most of them, 40% are occurring on the low voltage. These are the limits of the low voltage given in one of the references of electrical safety from where I have picked. I've not seen any exam questions based on this table up till now. It is just there to show the uh, show that the low voltage, low current are dangerous to the human safety as well. One of the commonly asked question is that who kills a person? It's a voltage or a current. Basically, it's a current which kills a person, because when the current flows through the body, inside the body, it causes that conductive burn of the organs, and due to those conductive burns, the person expires. What is the role of the voltage? The higher the voltage, the greater the amount of current will going to flow through the body in the shortest possible time. So it's basically the current which kills, not the voltage. Okay. So effect of AC current. Yes. Any questions?
Yes, sir. So like we have said, it's the flow of electron, right?
Yeah.
That is we call under ampere. So more the voltage is more, the current will be more, right? So
Yeah. For yes.
given time. But if we say, for example, like 50 volt, so somehow they say that if it is until it is even 50 volt, it can kill.
Yeah. In 50 volts for the human body, the amount of current flowing through the human body will be less than this 6 milliampere. So that won't be killing, but it will going to enter into some dangerous category. For example, if we use the formula of V is equal to IR, voltage divided by body resistance. So for 50 volts, and in normal condition, if we take 100,000 ohm as our body resistance, multiply by 1000. So this comes to be around 0.5 milliampere. So 50 volts, 0.5 milliampere, we have a tingling sensation is there. So that means this is the range in which some hazard starts. That's why they are trying to close, or they are trying to reduce the chances of electrocution at 50 volts if the body is wet. For example, if the body is wet and the human body resistance is only 1000, or let's suppose it has reduced to 10,000 ohms, multiply by 100. So that will be around, 50 divided by, it's 1000. I have to multiply it. No? I am multiplying it by 50 volt.
We'll keep
10,000. Sorry. So it will be around 5 milliampere. Okay, so 5 milliampere, if we look here from 6 to 9 milliampere, the shock becomes painful. Muscle control is not lost, but now the chances is there is that that a person will going to find himself in danger zone.
Okay, so that's why in Article 105, it is an electrical safe work condition. It is saying that voltage equal to or greater than 50 volt shall be put into electrical safe work condition because
Yeah.
of this reason.
Yeah, this is could be one of the reason that under different scenario they might have considered different type of the human body for kids, for girls, for boys, and for wet condition, for normal condition with sweating. So this is the voltage level which is considered as a safe voltage level.
Okay, sir. We have taken here ohms, like 10,000, let's say, or sometimes we say if it is dry, they say it is 100,000, right?
Approximate, it says that 100,000 ohms.
And if it is like uh, wet means like wet is like with sweet. If
Uh, it's not with sweat. It could be, or it could be if I'm working in some outdoor in under rainy condition.
rainy or water, but it's not, or maybe humid more than 70 or something, or 50% humidity.
Yeah, it could
Uh,
be. So in all those cases, the body resistance will be low.
so dry means that apparently if it is like no nothing like on the, so we consider that dry and like normal like we are without sweet and moisture and other things. So we call it
Yes,
dry.
yes.
Okay, sir.
So here in this case, in this chart, which is taken from electrical safety in the workplace source. So you see that in the milliamperes, when you are in the range of 6 to 9 milliamperes, shock is there, which is painful. No muscle control is lost. But when you move from here, the muscle control can uh, uh, could happen. So that's why you will going to find that most of the outdoor GFCI settings are based on 5 milliampere. So if a person is working outside, the GFCI are set to be at 5 milliampere or 6 milliampere, so that they fall into this category. If we increase,
Yeah. Sir, a quick question about GFCIs. Like GFCIs is can be used anywhere and everywhere, like with any kind of higher loads as well, or because with minor trips, any like with like it is about milliampere, so it gives a lot of trips like in construction. But what about like standard setting? In is it like a requirement or something?
GFCIs are being used in kitchens or in swimming pool area, in construction side as well. So in if you are using GFCI as a plug or the socket in your main building point, so the GFCI setting could be like 30 milliampere could be there. But if you are working at the outdoor and if you are using GFCI for the outdoor activities, so the lower the GFCI setting it is, it will going to protect the employee or the person who is operating. So the main purpose of the GFCI is to protect the employees, not the circuit itself. And GFCI only operates when there is some fault within the equipment or the hand tool or the portable equipment which that person is using. Okay, so so GFCI does not trip if there is fault in the electric. It's not an overcurrent protection, so it does not trip due to some overloading or due to some failure in the system. Basic, but it trips when there is a current difference. So that means if there is a current difference that uh, then the current is not following its path and it is getting short through a different part. For example, here if we see the GFCI working principle, so this is the current 5 milliampere, for example, going and returning back to the system, or 10 ampere this device is using, and the 10 ampere is feeding back. When there is some internal fault is in this equipment, the current will going to start to leak through through this human body, and the return path will not be seeing the exact amount of the current which was entering into this equipment. So when there is a difference of 5 milliampere, 10 milliampere, whatever your setting is, so that means that amount of current has started to pass through the human body and it is flowing into the ground. So when it senses that there is a difference of 5 milliampere, 10 milliampere, or whatever setting you have put, it will going to uh, operate and open the circuit. So if this equipment is using, if it is, if this equipment or this socket is being used for 10 ampere and I'm plugging it 20 ampere on that, GFCI will not going to trip, because GFCI will going to see that, okay, 20 ampere is going and 20 ampere is returning back into the circuit. That means there is no leakage there. Who should trip? The overcurrent protection device should trip, which is basically the watchdog for the overcurrent, whether there is overloading or not. But the GFCI will going to trip on the 20 ampere if there is a difference of 5 milliampere, 10 milliampere, whichever you have said, and GFCI will also going to trip if the socket has a capability of 20 ampere and you are running load only 5 ampere, but there is some leakage current is there, GFCI will going to pick that current and will going to isolate the circuit. Yes, am I able to clarify this point?
Yes, sir. Clear.
Yes, any questions from anyone? So what is a GFCI? A ground fault circuit interrupter, also called the ground fault interrupter or the residual current device, is a device that shuts off the electric power circuit when it detects the current flowing along the unintended paths such as water or a person. Yeah, let's have a ballot. What is the primary function of GFCI? The primary purpose of the ground fault circuit interrupter is the protection of the electrical equipment and system. It's false. Its first is primary function is to provide protection to the human body or the humans. So working principles of GFCI. Sorry. So a device intended for the protection of personnel that functions to de-energize circuit or portion, therefore within the established period of time when a current to ground exceeds the value established for a class A devices. And here they have mentioned the normal setting of the GFCI as well. A GFCI device operates quickly in 4 milliampere to 6 milliampere range to minimize the chances of electrocution or serious shock injury. Exhibit 107 through 100.9 shows example of device that provide GFCI protection. So there are different type of the device are being showed, which are used at different locations. Okay, moving towards the limits of approach of boundaries. There are two types of the boundaries covered in the standard. One is the arc flash boundaries and other one is the shock protection boundary. The shock protection boundary is further divided into the limited approach boundary and the restricted approach boundary. So what is this shock protection boundary, the limited approach boundary and the restricted approach boundary is there. Basically, we have seen that in order to receive a shock, you don't necessarily need to go and touch the conductors itself. But if you are in such a close proximity that there is a chances of the electric arc over phenomena is there, so we have to keep ourselves at a safe distance so that we are not being electrocuted. So that short distance is basically, or the clearance which is mandatory requirement, is the restricted approach boundary. The restricted approach boundary is basically the trigger point for the qualified person that they cannot enter this boundary until and unless they are wearing a proper shock protection person protective equipment. So what is the limited approach boundary? Limited approach boundary is the distance at which there is a chances of electric shock is there and to an unqualified employees. So unqualified employees should be kept away from this limited approach boundary. and any long handle tool, scaffold, or any other type of the material should also be kept outside of this boundary. And what is this arc clash boundary? It is basically the boundary at which there is a chances of second degree burn when the incident energy is around 1.2 cals per centimeter square. You see that they have mentioned that this arc clash boundary outside as well as inside as well. So what does this means? Normally, people think that the arc flash boundary is always the outermost boundary of the restricted approach boundary or the limited approach boundary, but this is not the case. The arc flash boundary can come within the limited approach boundary, and the arc flash boundary can come within the restricted approach boundary as well. And both of the boundaries are independent of each other. The arc flash boundary does not depend on the shock protection boundaries, and the shock protection boundaries does not depend on the arc flash boundary. What does this means? Let me show you one sample, then we will proceed. It's a sample report of the E hazard. Okay, that we will go to cover shortly. Let's discuss first important concepts, and then we will come to this one. Okay. So how it is calculated, the limited approach boundary, restricted approach boundary, and the arc flash boundary, and where you will going to find further information. You can turn up to informative annexure C, which is basically the limits of approach of boundaries. In this annexure C, you will going to find further information or the information related to this limited approach boundary, restricted approach boundary, and the arc flash boundary. So at this point, just keep in mind that the shock protection boundary is independent of the arc flash boundary, and the arc flash boundary is independent of the shock protection boundary. For example, 70E says that if you are working on a system which is operating at 50 volts, the shock hazard exists. If you are working on a system where the incident energy is 1.2 cals per centimeter square, the arc flash hazard exists. So there could be some situation and scenarios in which I'm working at 50 volts. So the shock hazard exists, but the incident energy is not there greater than 1.2 cals per centimeter square. So the arc flash hazard does not exist. So once the arc flash hazard does not exist, so this arc flash boundary is also not there. So in this scenario, the shock protection boundary exists, but the arc flash boundaries does not exist. For example, yes, any questions?
Yes, sir. By the way, sir, this figure is not showing any. It is only like mentioning arc flash boundary and then limited and then restricted.
Yeah.
And that's it. It is not showing.
What it is not showing?
Shock.
Basically, the shock protection boundary is limited approach boundary and the restricted approach boundary. These two boundaries are the part of the shock protection boundaries. So here in this report, you can see that there is a plant with a bus number 1. At this voltage level, the amount of incident energy is 0.80, but the voltage is 480 volts, 0.48 kV written here, and the incident energy is 0.80. So that means for this location, the incident energy is the arc flash hazard does not exist. The arc flash boundary will not be there, but the 480 volts is there. So the shock protection boundary and the arc flash boundary will be developed. How we will going to develop those shock protection boundary and how we will going to develop this limited approach boundary and the restricted approach boundary? We will going to refer to table 130.4 EA. The shock boundary approach boundaries to expose energized selective conductor or circuit part, which is given on page number 28 of the standard. You can see that 50 volts, 70 does not specify the limited approach boundary and the restricted approach boundary. That means till 50 volts 70E does not take into the consideration that this voltage will going to result you shock hazard. Above 50 volts, from 50 volts to 150 volts, then up till 880 kV, we can see that the boundaries are increasing. From 50 volts to 150 volts, the limited approach boundary is 10 feet for the movable conductors, and it's fixed for the and also for the exposed fixed conductor. So what is the difference between the exposed movable conductor and exposed fixed circuit parts? Exposed fixed circuit parts are like busbar inside your panel, which are fixed. What are the exposed movable conductor? The overhead line conductors. Or if I'm working at a certain location where I'm working on I'm standing on some scaffold, and there is some play in the scaffold. That means that scaffold it can move slightly. So that will going to fall under the exposed movable conductor. If an exam they ask us to calculate the limited approach boundary and the restricted approach boundary for a particular situation, and they give us the example that a person is working on some overhead line pole. So this will going to, we have to use column number 2. Yes, please. Yes,
sir.
Zishan.
The overhead line is considered to be movable conductor, right?
Yes,
Yes,
because here is a sag there, and due to wind, the conductors can move a bit.
And underground lines are, we can say them fixed, right?
But those are not exposed. So those are not exposed. So directly there is no shock hazard associated with those. But the bus bars, for example, the bus bars inside the panels, the bus bar inside in your switch gear, switch rooms, those will be considered as exposed fixed circuit parts. So here you can see that exposed movable conductor describes a condition in which a distance between the conductor and a person is not under the control of a person. The term is normally applied to overhead line conductors supported by poles. So this distance is not under the control of a person. So that distance can be reduced if there is some heavy wind is there due to the sag. The conductors can move a bit right or left. So this distance will be reduced. So if this is type of the condition, we will be using this column number 2. Okay, in this column number 2, for example, in exam questions come that that a person is working, that a person need to work on 33 kV voltage level. What is its limited approach boundary and the restricted approach boundary, and that is an overhead line. So we will going to come here on this 36 kV, 33 kV going to fall under this range. We will look into column number 2, and that is basically the 10 feet is there, and the restricted approach boundary will be 2 feet. If it is a fixed conductor, then we will be using 6 feet, not the movable conductor. And other example is that if that voltage range does not fall in this table, for example, here it is for example 132 kV. They ask about you 132 kV. So here it is 121 kV and here is 138 kV. So we will going to jump into the highest one, and we will going to assign the distances related to the higher voltage level. So in this row, it is from 72 kV to 121 kV, and in this row, it is from 138 kV to 145 kV. So in this particular case, we will be covering, or we will be looking into the voltage level, which is the higher one. So the answer will be, if it is an overhead line, then the limited approach boundary will be 11 feet and the restricted approach boundary will be 3 feet. And on the other hand, for the fixed conductor, the limited approach boundary will be 10 feet and the restricted approach boundary will remain same. So why it is like this, that the limited approach boundary is 2 and the restricted approach boundary is defined as only 1. So from here, the questions arises, then what's this boundary basically trigger? So we have to keep in mind that the limited approach boundary basically triggers is basically the triggering point for unqualified person. So you have to keep your unqualified people away from those energized circuits and conductor parts, minimum of the limited approach boundary. Okay, he is not allowed to enter the limited approach boundary until and unless he is escorted by the qualified person. Otherwise, he's not allowed. What triggers the restricted approach boundary? Restricted approach boundary triggers that only a qualified person can enter the restricted approach boundary when he is wearing the appropriate personal protective equipment and he has work permit with him. Then he can come and perform the job. Under no condition, unqualified persons are not allowed to enter the restricted approach boundary. So if we see, if we have a transformer room and it is energized, so these are exposed energized conductor and circuit parts. So we will going to calculate the restricted approach boundary and the limited approach boundary. So this limited approach boundary is basically triggered that we have to keep our unqualified person away from this limited approach boundary. No unqualified person is allowed to enter the limited approach boundary until and unless there is some emergency or he has to enter in order to pass or cross, not to perform any job there. He should be escorted by the qualified person. What does this mean by the escorted? Escorted means the term where they are using under the supervision of the qualified person. Only qualified person is allowed to cross this restricted approach boundary and come into the restricted approach boundary in restricted space if he is wearing the appropriate personal protective equipment. So let's review the definitions of the shock protection boundary. The limited approach boundary is the distance from an exposed energized conductor or circuit part within which the shock hazard exists. The boundary is typically closes a person that is not a qualified person may approach and expose energized conductors or the circuit part. What is the restricted approach boundary? The restricted approach boundary is the distance from an exposed energized electric conductor or circuit part within which there is an increased likelihood of electric shock due to an electric arc over combined with an inadvertent movement. What are the chances of electric shock? I might not be touching the electrical equipment or electrical conductor or circuit part, but the chances of electric shock is there due to electric arc over phenomena and due to this inadvertent movement. So this is typically the closest that a qualified person can approach and energize exposed circuit parts or conductor without voltage rated personal protective equipment. So if any qualified person need to cross this restricted approach boundary, he will be wearing those R-rated personal protective equipment and it's a mandatory requirement. How we will be calculating these two boundaries? The voltage levels will be given to us. So for the AC voltage level and if it is a movable conductor, we will be using column number 2. If it is a fixed conductor, we will be using column number 3. If and for both, the restricted approach boundary will be same. In exam, we have to make sure whether it is talking about the alternating current or the direct current. If it is a DC current, then we will be using table 130.4 EB. Oh, okay, so for those direct current, the voltage level will going to remain same. Less than 50 volt is not specified. And as the voltage will going to increase, the limited approach boundary and the restricted approach boundary will also going to increase. So we can have a comparison that for the AC system at 800 kV, the limited approach boundary is around 7.2 meter and 4.9 meter. And for the DC circuit, it's more. the limited approach boundary is 8 meter, and it's and the restricted approach boundary it's 3 meter. So the increase in the limited approach boundary and the restricted approach boundary for the DC system is more as compared to the AC system. Okay, just to summarize, the limited approach boundary is basically the triggering point. Unqualified person should be kept away from this limited approach boundary. He is not allowed to enter the limited approach boundary, and he must never cross the restricted approach boundary. Long tools, handles, those scaffold or ladders are also not allowed to be bringing into the limited approach boundary. Scaffold is also not allowed. Only qualified person are allowed within the restricted approach boundary. The qualified person can escort those unqualified person who are within the limited approach boundary, but they are not performing any tasks. They are not performing any task within this boundary, but they might have to cross those boundaries. So it is a requirement that they must be escorted by the qualified person. When a qualified person is within the restricted approach boundary, he should be wearing all the personal protective equipment, appropriate PPs, and if required, if the task requires that, he should be having an energized electric work permit. So he will be holding that energized electric work permit as well. Yes, any questions up till now on this one?
Sir, somewhere I have seen they call it a prohibited boundary that is inside the restricted.
That was till 2012 and 15, I think.
Okay.
Since 2018, I've not seen prohibited approach boundary. Basically, the prohibited approach boundary says that you should not touch the electrical equipment or circuits with your bare hand. So who will going to do it? So basically, this prohibited approach boundary was removed from I think 2015 onwards, because it was not triggering anything. From restricted approach boundary, it is make clear that only a qualified person will be entering those restricted approach boundary with wearing all the personal protective equipment PPs. Okay, and will be using insulated tools to perform the task. So there was no requirement left for the restricted approach boundary. That's why no requirement left for this prohibited approach boundary. That's why it was removed from the standard. When you will going to start reading this standard, start with this forward. Okay, how this standard have developed over the period of time. You will going to find here in 2021 edition, the prohibited approach boundary was deleted because additional protective equipment was not required when crossing this boundary. So this prohibited approach boundary was not triggering anything, not related to qualification of a person, not related to personal protective equipment. It was not even highlighting that it's a requirement to have some special equipment or any other protection is there. So that's why this prohibited approach boundary was removed from the standard. Okay. All good. Right. Before starting some Q&A, if you people can put on your cameras, it's because it's one of the requirements that have been stated towards me for today's session, that we have to capture the picture. So I will request you all please to open for a minute or so. Yes, Mr. Zishan, Mr. Janzeb. Sabir, your face, front camera, please. Yes, Mr. Janzib, Mr. Zishan. Okay, anyone can use its print. Yes, Mr. Zishan, if you can open it, please. Oh, you look good. Yeah, Mr. Janzib. Can anyone capture what method we should use for capturing the picture? The print screen is not working for me.
Let me check, sir.
Yes, Mr. Janzib.
Uh, can you, I think if uh, you unshare or something for a while, maybe.
Oh, okay.
So
We can take all. Just a second, please. Mr. Janzib, you are not online up till now. We can have a speaker gallery. Sabir, if you can again, please pop up. Just a second. So sorry for this one. Thank you all. Let me save this one. Okay, let's move. Screen is shared. Yeah. Let's move to some Q&A related to today's topic. Okay, the limited approach boundary is the shock rotation boundary, which is calculated by knowing the system voltage and the available fault current. The answer is false of this one, because for the limited approach boundary or the restricted approach boundary, which is basically the part of the shock rotation boundary, if we know the voltage, we can do it. There is no requirement of knowing the fault current. If you look into this table again, yep, this one. So we can calculate the limited approach boundary and the restricted boundary if only we know the voltage level. So there is no requirement of knowing the fault current. Okay. Moving to next one. The limited approach shock protection boundary is the approach limit for qualified employee and is intended to eliminate the risk of contact with an exposed energized electric conductors or circuit bars. Yeah, this is true. Right. So these are some of the basic questions which we have covered and the topic which we have covered related to the shock hazard. We will going to stop here today. and we'll be starting the rFlash hazard and the rFlash risk assessment and other topics in detail in the coming session. Okay, so what's for you people? Just start to go through the standard. I think you people have got this soft copy of the standard. The standard is with you.
Sir.
No. Okay, I will ask Mr. Johar to how the soft copy can be provided to you people and other documents which I have. Okay, I will discuss with him the options. Okay, so once you have got this soft copy, just start to read this this standard from starting the forward. Read the forward so that you know that how this standard has developed over the period of time, and now it's I think 11th or 12th revision, so it is in very mature state. What we have covered up till now, we have covered annexure K, and we have covered annexures. We have slightly covered annexure C. So in today's class, we have talked about this limits of approach of boundaries. Okay. So this is a bit covered, and we have covered this annexure K today. Which is related to the electrical hazards. Yep, this one, general categories of electrical hazards. Just go through this annexure K today as a part of your reading assignment. Okay, thank you all for joining today's session. See you on Friday. Thanks a lot. Bye.